Okay, just check it out whether you can hear me. Okay, so let us start with our class, regular class. This is for Airport Authority of India. We are doing physics. This is my second lecture, physics made simple lecture. And today also I'm going to discuss with you one of the very important chapter, one of the very important lecture from where very frequently questions are asked. Let me tell you, the questions which are asked in this exam, you need to have practice for that. You need to know the concepts. I don't say this is the difficult exam, but yes, competition is also huge. So you need to score really good. Out of 120, you need to score more than 90 to get the score. Then only something will come out of it. So you need to score good for this particular exam, right? So today I'm going to, last class mein I had taken some topics from where questions had come, and today also I'm going to take a topic from where questions have been asked. And the name of the topic is gravitation. Gravitation may say frequently questions are asked. Also, I will tell you that do not depend only upon previous year's pattern. Previous year's pattern was highly inclined for electrical electronics students, but this year the pattern may be inclined for mechanics also, because maximum posts are open for mechanical and civil and other engineering graduates, and open engineering graduates also. So it can be, I mean, pattern can be different. So just stick to the pattern which is being done by us. Okay, let me give you first theory, and then we go for the questions which were asked in Airport Authority of India. And I've already sent you the WhatsApp, the questions which I'm going to discuss with you today. So let me first discuss the concept of gravitational force. If there is a mass capital M, and if there's a mass small m, and let us say radius to radius distance between these two is r, radius to radius, then there's a gravitational attraction force which is G capital M small m by r square. Assuming that capital M is the larger mass and this capital M is attracting the small m, so there's a gravitational pull force G m by r square. R is the distance from radius to radius. That is how it is. Now all we should know is capital G is called universal gravitational constant. This is the universal gravitational constant. This is universal gravitational constant, and its value you can remember is 6.67 into 10 raised to power minus, we can say 10 raised to minus 11 SI units, which is Newton. You can see force per Newton meter square per kilogram square. You see, understand this. So this is the value of universal gravitational constant, 6.67 into 10 to minus 11 Newton meter square per kilogram square is the value for this. Sometime he might ask you the dimension of that. Units and dimension chapter is also there in the syllabus. How do you find the dimension for this universal gravitational constant? Dimension of the force is mass into acceleration, mlt minus 2. Dimension of mass, this is m square. Dimension of this is L2. So what is the dimension of G then? mlt minus 2 into L2 over m2. What do we get is m minus 1 L3, m minus 1 L3 t minus 2. So this becomes the typical question for units and dimension chapter m minus 1 l3 t minus 2. He's not going to ask you units of very very simple things. He's going to ask you the units of those parameters which actually are interpreted. So gravitational force formula is g m by r square. G is universal gravitational constant, m is the mass, r is the radius. So how we get the unit for this, and how do we calculate the value of this particular universal gravitational constant? So value you need to remember, and force value you need to remember. Let's go forward and let me give you some more concepts which are required in this particular formula. Okay, now let me give you, this is earth, radius of earth is r, let us say, and there's a body which is on the surface of earth, and this body experiences acceleration due to gravity, which is value of acceleration due to gravity we know is g. So this is earth and the body is on the surface of earth. Okay, now mass of the earth is m. So what is the gravitational attraction? G, mass of earth, small m, over radius of earth, r square, is equal to the weight of the body. The force which earth applies on this mass, the force which earth applies on this mass because of gravitational attraction, is this force जो न्यूटन्स लॉ ऑफ ग्रेविटेशन से हमने निकाला, g m by r square. Small m is the mass of the body, small m is the mass of the body. So what we understand from here is g capital M is equal to g r square. This is very very important. G is universal gravitational constant. This is mass of earth, we know mass of earth also, and this is acceleration due to gravity, 9.81 meter per second square. This is radius of earth, 6400 kilometer is the radius of earth. So remember, this is important formula which will be used in this particular chapter in many places, right? This is how we are to calculate it. Okay, how can we calculate? Let's say density of the earth is rho, and earth is assumed to be spherical shape. So what is the volume of earth? 4 by 3 pi r cube. If I multiply that with the density, it becomes mass of earth. So mass of earth can be written as 4 by 3 pi r cube into rho, right or not? So if I write this thing here, it becomes g into 4 by 3 pi r cube into rho is equal to g r square. Then r gets cancelled out. This becomes g is equal to 3g over 4 pi r, and this is the value of rho. You understand? So 3g r square, one value gets cancelled out, pi r, 4 pi r, and into rho. This is how we can think of calculating universal gravitational constant, because in one of the questions he has asked you how universal gravitational constant changes with basically various parameters. So this g value actually can be calculated in terms of this. If we know the radius of earth, if we know the acceleration due to gravity, and if we know the rho value, this g does not depend upon it. I'm not saying g depends upon it, but this g was found out by basically some experiment. I think that experiment was, let me tell you, that experiment value was Cavendish experiment. You know, this was Cavendish experiment through which g was found out. But yes, g can be calculated using these values. That is the meaning of it. So this is how we can calculate, and at the same time small g can also be calculated as 4 by 3 pi rho into capital G R. So this is how two values of small g and capital G can be calculated. That is the another thing which we should know. Okay, now what we understand is acceleration due to gravity. G depends upon what? G depends on what parameters? That is very very important. So what are the values on which G depends? Number one, it depends upon the mass of earth. Mass of earth, yes, it depends. Not on the mass of body. Not on mass of the body. Yes, we know that. It depends upon shape of earth. Yes, it depends upon the shape of earth also, right? We will see that particular formula how G variation is there. It depends upon height and depth. Yes, it depends upon height also, and it depends upon depth also. These two things on which this particular thing depends. Now I start discussing about the variation of G. What is the variation of G? Let me discuss about that. how the g is varying. So if I tell you number one about the shape, earth is something like this. Earth is something like this. It is equator. It is equator, and this is called pole. What about G on pole and G on equator? So what about G on pole and G on equator? This G is Gm over R square. So if we take it on pole and if we take it on equator, this is how we are going to get. So radius on the pole and radius on the earth. You understand if I ask you acceleration due to gravity is more on equator or it is more on pole? You understand? Pole ke upar radius is rp, I am saying, and equator ke upar radius, let us say, is re. And there is a basically relation we have between re and rp. We understand radius on equator is more than radius on pole. That is something which we already know. And hence, if we take the ratio of these two, GE over GP, then that comes out to be RP over RE whole square. This is what we are going to get. So acceleration due to gravity on equator, acceleration due to gravity on pole basically depends upon this. And you know what? Acceleration due to gravity on pole is more than that on equator. So acceleration due to gravity on pole is more than acceleration due to gravity on equator, and there's a small value which we calculate, and that is 0.18 meter per second square. So somebody asks you, where do you get maximum acceleration due to gravity on earth? You will say on the pole. How far it is, how much it is more than that on equator? So you will say it is 0.018 meter per second square more than that on the equator. That is what we should know. Now second is variation of g with height. These two relations are something which are very very important. Variation of g with height. Okay, now this is the surface of earth, radius is r. I give you now a point which is r distance from the center of earth. Can you calculate what is g here? Yes, this is gm over r square. What about g on the surface? It is gm over r square. So can you tell me the relation between the two? Yes, g dash by g is equal to r square over r dash square, or sorry, r square. Okay, now suppose I give you height. What is the height? Height is h. And what is r? R is nothing but r plus h whole square. So this is the actual formula. This is the actual formula. So g dash is equal to r over r plus h whole square into g. This is the actual formula. So you people are going to use majority of time this formula. So how acceleration due to gravity changes with the height? Sir, this is the formula. What height, at what height? If h is very very small, then the formula is simplified using binomial expansion. What do we do is, we say, okay, binomial expansion, we say g dash is equal to g r square over r plus h whole square. I take r common, g over 1 plus h over r whole square. Okay, I take it on the numerator, 1 minus h by r whole square. And if I open through binomial expansion, this formula becomes something like this. But this formula is true only if h is far far less than r. Then this formula is true. So acceleration due to gravity at height h, there are two formulas I am giving you now. Acceleration due to gravity, how it varies with the height, I'm giving you two formulas. 99% of the time try to use this formula. This is the actual formula. But if h is very very small, let's say r is 6400 kilometer. Now suppose he gives you 1400 kilometer, 1600 kilometer, then you are to use this formula. But suppose he gives you 10 kilometer, 20 kilometer, then 10 and 20 kilometer can be neglected compared to capital R. And in that case, G dash will be G into 1 minus 2H over R. So this is how you need to remember the formula. So if height is very small, then acceleration due to gravity we can calculate, and that is this formula. If height is more, then this is the formula of acceleration due to gravity which we have to use. So acceleration due to gravity, how the variation is there with the height, two formulas. Exact formula, approximate formula. Done. I go forward now and I find out now how the this acceleration due to gravity changes with depth. So G with depth, G with depth, let's say D is a very very simple formula. Let us say from the surface I am taking D meter below the surface of earth. This is the radius, and I am calculating G dash. Now G is the surface acceleration due to gravity on the surface, and G dash is acceleration due to gravity D meter below the surface of earth. For that, what I am to do is I am to take a small now sphere. I am to consider its mass, because acceleration due to gravity at this point will be because of the smaller basically radius, that is small r, and which is nothing but capital R minus D. What is D? D is the depth. So I'm calculating acceleration due to gravity at this point. How far is this point from the center? Small r. And how much is the small r? Capital R radius minus D. Now I need to consider the small sphere of radius r minus D, calculate its volume, calculate its mass, because the density is same. We are assuming density is same, and then we calculate what is the mass of this small sphere, and proportionally we calculate the acceleration due to gravity. I'm not calculating the value, but I'm giving the value. G dash is G into 1 minus D by R. This is the formula you need to remember. Is this approximate formula? No, this is not approximate formula. Was this approximate formula? Yes, this was approximate formula. Was this actual formula? Yes, this is actual formula. And what about this formula? This is the actual formula. This is not approximate formula. So if you see now, the variation of acceleration due to gravity with the height is parabolic function. As the height increases, acceleration due to gravity decreases. The variation of acceleration due to gravity with the depth is a linear function. With the linear, it changes linearly. So it is basically changing the linear. It is a linear function. It is changing linearly. So acceleration due to gravity changes with the depth also, with height also, and I've given you two formulas. Now very very important formula is how G changes with latitude. So what is latitude now for me? You should know what is the meaning of latitude. I mean at angle. When I'm saying latitude, that also means angle. How acceleration due to gravity is changing with the angle. That is the second thing which we should know. Let me give you the meaning of latitude now. Earth is a basically spherical shaped body. We understand that. Let me make this shape here. And let us say this is equator. And I'm giving you a point somewhere here which is at lambda angle, something like this. I'm giving a point which is at lambda angle here, and then you know what, I want to find out how this particular acceleration due to gravity at this point will change. Let us say earth is rotating at omega radian per second. So this is with angle or with earth speed. We have two formulas here. Now understand, there are two things. When there's a body which is on the surface of earth and earth is rotating, then there's a centrifugal force acting on that body which will be radially outward. Centrifugal force radially outward. How much is the centrifugal force acting on body? mr omega square. Listen carefully. We are on the surface of earth and earth is rotating. If earth is rotating with speed omega radian per second, then you know what, with this speed there will be centrifugal force acting on the body, and that centrifugal force will be acting outward. And acceleration due to gravity is attraction force. So mg अंदर की तरफ, mr omega square बाहर की तरफ, and sum total of these two forces will actually provide me the real value of G dash. Okay, so what is the value of G dash which changes because of lambda and because of omega? Let me give you this formula. Memorize this formula. G dash is G minus r omega square cos square delta. Just remember this formula. What is lambda? Sir, lambda is latitude angle. As you can see here, lambda is latitude angle. What is the value of lambda at equator? 0. And if it is at equator 0, cos 0 is 1. And hence, the minimum acceleration due to gravity is at the equator. How much is that? Sir, G and G minus r omega square. This is omega square. And what is this G here? This G is the acceleration due to gravity which we get at pole, because if lambda is equal to 90 degree on the pole, then G dash will be equal to G on the pole, and G dash will be equal to G minus R omega square on equator. So you can understand again that on the pole we get maximum acceleration due to gravity, and on the equator we get minimum acceleration due to gravity. So I'm going to give you only three formulas of variation of acceleration due to gravity. One with height, उसके दो फॉर्मूले हैं, एक एग्जैक्ट और एक अप्रोक्सीमेट. दूसरा विद डेप्थ, जिसका एक ही फॉर्मूला है वो एग्जैक्ट. तीसरा विद स्पीड एंड एंगल, लैटिट्यूड, स्पीड ओमेगा. सो एज अर्थ इज रोटेटिंग, अर्थ रोटेट कर रही है तो एक्सेलेरेशन ड्यू टू ग्रेविटी विल बी रिड्यूस्ड. इफ वी कंसीडर द रोटेशन पार्ट, then acceleration due to gravity will be less. So acceleration due to gravity G dash is G minus R omega square cos square lambda. What is R? Radius of earth. What is omega? Rotational speed of earth. How do we calculate that? 2 pi by t. T कितना है अर्थ का? How much time earth takes to complete one revolution? 24 hours. You understand? And lambda is the angle. So at the pole lambda is 90 degree, and hence this part becomes 0. G dash is equal to G. And at the equator this lambda is 0, and hence this is G minus R omega square. So somebody asked us, what is the difference between acceleration due to gravity on pole and equator? We will say R omega square. What is R? R is the radius of earth. What is omega? Omega is the rotational speed of the earth. This is how we can calculate that, and this value we have just now calculated, written 0.034 meter per second square. This is the value of difference of these two. That is how do we get it. Okay, now we understand this is the thing we have calculated. Also there is a way to calculate angular velocity of the earth. We have seen that G dash is equal to G minus R omega square cos square lambda. Now at the pole, if I give you, at the pole lambda is equal to 90 degree and G dash is equal to G. So G is equal to, at the pole if we see, G dash we will get is, at the pole if I give you, G dash will be equal to G minus R that is omega square cos of 90, which comes 0. Then this is the value of acceleration due to gravity at the pole. Now suppose I tell you about the equator, then lambda will be 0, and at the equator we get the value of 0. So from these two values, let me now not write this all. From these two values we have obtained that G is equal to, G dash is equal to G, and G dash is equal to G minus R omega square. This is at the pole, this is at the equator, and from these two we can calculate the difference. That is what we have written in the previous slide also. That is the same thing which we have written. Okay, now how to find out the omega? As I told you, omega is 2 pi by t, and t is 24 hours, or we can say 24 into 3600 seconds. That is the time period of rotation, and from there we calculate the angular velocity of rotation of earth. I don't think we should remember the value of angular rotation of earth. Okay, this is one part we have done. Now let me here discuss one part here, and then we go for some numerical and some more part. I will discuss with you a topic, escape velocity. Maximum time the question has been asked from this particular part, escape velocity. How shall we escape from the field of earth? How shall we escape from the field of earth? So suppose I throw something from the surface of earth, can that body escape the gravitational pull of earth? Now see, this is the most important topic in this chapter. This is the surface of earth. I want to throw something above surface of earth with some velocity so that it goes out of the gravitational attraction of earth. Now how to prove this? How shall we get it? Let us say I take a body at distance x from the surface of earth. I take a body at distance x from surface of earth, and I move it by distance dx, and I move it by distance dx. So how much will be the work done? How much will be the work done to move this body by dx? So small work done will be G capital M. This body is of mass small m, over x square into dx. What we have written is small elemental work required. Small elemental work required to move a body of mass small m by small distance dx against the gravitational pull of earth. Because when we are saying escape, then we need to escape the gravitational pull of earth. So if I give you a body of mass small m, and this mass small m is to escape the gravitational pull of earth, I'm taking integration concept. I'm saying that let us say gravitational pull at this point is gmm by x square. Let's say the small work done to move it by small distance dx is gmm by x square into dx. Now what will be the total work required? Total work required to move the body from distance radius of earth to infinity. Now see here, this is the radius of earth, and I want to move the body to infinite distance. So how much will be the work required to move the body from the surface of earth to infinite distance? That is gmm by x square. That is the value we are going to get. But you know what, that will be obtained, this work will be provided through the, this will be provided through the kinetic energy given to the body, given to body. Now let us say the kinetic energy given to body is this much, half of mv square. तो मैंने क्या किया, मैंने एक बॉडी ली, उसको v escape से फेंक दिया, उसको मैंने kinetic energy दे दी half of mv escape square. That value should be equal to this. Now everybody will tell me that 1 by x square dx integration is minus 1 by x. You understand that? Minus 1 by x. And if I integrate it from r to infinity, this will be r to infinity, this will be 1 by r. So this value comes out to be g capital M small m by r. I am sure you know how this integration has come up. And now this is equal to g capital M small m by r. M gets cancelled out. What is v escape? g2 gm over r. This is the escape velocity formula we have got, and very, very important formula. This is the escape velocity formula for us. But you remember one thing, that we said gr square is equal to g capital M. We have already written this, that gr square is equal to g capital M. So instead of this gm, I can also write v escape as equal to, instead of this I write 2g r square over r, that means 2g into r. That is another formula of the escape velocity I can write. And obviously I need to take the under root of that. Sorry, I have not taken under root here. I need to take the under root of this. So we get two formulas of v escape now. One is 2gm by r under root. Another formula is 2gr under root, as we have written. And we know that there is a formula between g, and that is 4 by 3 pi rho g into r. That is what we have written just now, acceleration due to gravity in terms of density. So we get third formula is r into 8 by 3 pi g rho under root. That is the third formula of escape velocity. So let me now summarize escape velocity concept. As I told you, maximum questions have come from here. Let me summarize it again. What is escape velocity? How much velocity should I give to a body so that it escape the gravitational pull of earth? Acha, let's assume a body which is at distance x, and how much work needs to be done to move it by small distance dx, gmm by x square into dx. Acha, how much work I need to do so that it goes from the surface of earth r to infinity? This much. And but that should be given by kinetic energy, half of mv escape square. So what is the formula of v escape? 2gm by r. But that is gr square is equal to g capital M. And understand, this m is the mass of earth, not of the body. Body का mass small m gets cancelled out here only. You understand? So escape velocity के हमारे पास अब कितने formula आ गए? Escape velocity का सर एक formula 2gm by r. G is the universal gravitational constant, m is the mass of earth, r is the radius of earth. Second formula is 2gr. Third formula is, because g can be written like this, third formula is in the form of density. Now let me tell you, escape velocity किसके ऊपर डिपेंड करता है? अगर हमसे पूछेंगे escape velocity depends upon what? एस्केप वेलोसिटी किसके ऊपर डिपेंड करता है? तो वी हैव टू से इट डिपेंड्स अपॉन द मास ऑफ अर्थ. It depends upon mass and radius of earth. It depends upon mass and radius of earth or any planetary body. It depends upon that particular thing. And not only radius of earth, we can say acceleration due to gravity also, small g also. Yes, it depends upon gravitational, universal gravitational constant also. G, capital M, R, इनके ऊपर depend करता है. Small g, because these are also related, you know. Small g is also related to mass and radius of earth, and capital G इनके ऊपर depend करता है. Now, suppose he asks you, does it depend upon the mass of the body? Yes, does not depend upon mass of body. Does not depend on mass of body. Mass of body के ऊपर depend नहीं करता है. Number next point is does not depend on angle of inclination. Does not depend upon angle of inclination. तो ये angle of inclination के ऊपर भी depend नहीं करता है. तो escape velocity किस किस चीज पे depend करती है? Mass of the earth, radius of the earth, universal gravitational constant, acceleration due to gravity, these are dependent. And it does not depend upon the mass of the body. It does not depend upon किस angle पे तुम projection कर रहे हो. Projectile motion पढ़ेंगे बाद में, but escape velocity does not depend upon the angle of projection. Okay, I think now before going for next, I will be covering this gravitational chapter in two parts, in two lectures. So before going for next, I would like to go for numericals and questions जो इस part में से अभी तक पूछे गए हैं. Okay, let me give you Airport Authority of India का जो question अभी तक आया है. Let me give you first those questions, right? 3 questions. I think I should do that. 3 questions or 2 questions. Yes. Okay. Question is this: velocity with which a projectile must be fired. Velocity with which a projectile must be fired so that it escapes Earth's gravitational pull. Depends on mass of earth, mass of projectile. I think does not, it is not, does not depend on. That is the question. So these are 4 things he has given: radius of orbit, and fourth is gravitational constant. So that is what the question is. ये 4 चीज वो दिया है उसने आपको. And the question he asked is velocity with which a projectile must be fired. Now this is the surface of earth and I fire a projectile. You understand? So velocity with which I should fire a projectile so that it escapes the gravitational pull of earth does not depend upon what? So it does not depend upon mass of projectile. Mass, radius, universal gravitational constant, acceleration due to gravity, it depends upon all, except it does not depend upon this. So I'm very sure you people have understood the concept behind this escape velocity. And as I told you, escape velocity is something which is very, very important concept. That is what we should know. Now, let me give some more questions. Let me tell you some more questions which have been asked from this particular Airport Authority of India exam. Okay, let me give you this question. This question was also asked: if G is acceleration due to gravity on surface of earth, surface of earth, its value at height, its value at height equal to double the radius of earth. Double the radius of earth is, choices given are g, g by 2, g by 3, g by 9. You know, this is the question. H height पे acceleration due to gravity is g dash, and surface of earth पे acceleration due to gravity is g. And asking you if what is g dash in terms of g. Now, what is the value? We know value is how we have calculated with the height. You know, should I take you back? Variation. Which formula? Let me ask you this, because this is yes. Which formula do you think we should use? G dash over G. G is proportional to, you know, Gm is constant, capital G, M is constant. So G is inversely proportional to R square. You understand that? So G is inversely proportional to R square. So if I go here, let us say this is the R. So G dash over G is equal to R over R whole square. R over R plus H whole square. And what is H? H is nothing but at the height equal to double the radius, 2R. H is 2R. So R by 3R, 1 by 9. G dash is G by 9. That was the question. G dash is equal to G by 9. So that is the question number 1 which I've asked you. Okay. Similar question. Let me give you similar question. If acceleration due to gravity is given as 10 meter per second square on the surface of earth, this is on surface of earth, and its value is 10 meter per second square. Acceleration due to gravity on the surface of earth is this. Then at height 1600 kilometer, what will be the value of G? If I give you height which is 1600 kilometer, find the value of acceleration due to gravity. And he has given you some choices also, right? He has given you some choices also. Just calculate what will be the value. And the choices given are 6.4, then 5, then 7.5, then 2.5 in meter per second square. Meter per second square. Again, I will say G dash over G is equal to R over R plus H whole square. That is the formula we will use, because 1600 is too much, you know. 6400 plus 1600 whole square. This value is 10. What is G dash? I think G dash will come out to be 6.4. That will come out to be 6.4 meter per second square. I think this question also we can calculate. Okay, let me go for question number now 3. Let me go for question number 3. So this question also is given in your assignment. The height from the earth surface at which, so question is height from surface of earth, height from earth surface at which acceleration due to gravity, acceleration due to gravity reduces, acceleration due to gravity reduces to 1/4 of its value at earth surface, at the earth surface, which is assumed to be 6400 kilometer, will be how much? Choices are 6400 kilometer. Next choice is 2649 kilometer. Next choice is 2946 kilometer. And next choice is 1600 kilometer. Read the question. Height from the earth surface at which acceleration due to gravity reduces to 1 by 4th. So what is the question? G dash by G is equal to R over R plus H whole square. Now G dash becomes 1 by 4th of G. This is 1 by 4. So R over R plus H is equal to 1 by 2. Tell me what should be the value of H? Very clear, reverse substitute करो. ये 6400 है, तो if I make this H also 6400, then answer will be 1 by 2. Reverse substitution is going to work for us. This should be reverse substitution now. Okay, let me go for next question, and this is that next question. It says acceleration of a body due to attraction of earth. Acceleration of a body due to attraction of earth radius r at distance 2r from surface of earth is, what is acceleration due to gravity at a point? That the question is at a point distance 2r from surface of earth. Surface of earth, and this G is at surface of earth. So what will be the acceleration due to gravity? G by 9, G by 3, G by 4, G. This is the question. What is acceleration due to gravity at a point distance 2r from surface of earth if G is at the surface of earth? All we know is G dash over G is equal to R over R plus H whole square. So at a point distance 2r, R over R plus 2r, I think this just now we did 1 by 9. So G dash is G by 9. I think this is just now we did. Okay, this is the same question. Oh, let me go for next question now. This is related to escape velocity. Please read this question carefully. Escape velocity for rocket from surface of earth, from the surface of earth is 11.2 kilometer per second. And you remember this value also. If you put all the values together, this is 11.2 kilometer per second. Its value on a planet, where its value on planet where acceleration due to gravity is double. Acceleration due to gravity is double than earth, and the diameter of planet is twice that of earth. So what will be the value? 11.2, this is 5.6, 22.4, 53.6. So that is the question. Escape velocity for rocket from the surface of earth is given as 11.2. Now tell me what will be the value of escape velocity on another planet where acceleration due to gravity is double that of earth and diameter of the planet is twice that of earth. Good. So now escape velocity, what we found the formula is 2gr under root. So acceleration due to gravity on earth, radius, if diameter is double, radius is also double, right or not? So now escape velocity on planet, escape velocity on earth is equal to g on planet, radius on planet, g on earth, radius on earth under root. Now he says acceleration due to gravity double हो गया और diameter भी double हो गया, तो 2 into 2 under root. So that means it is 2 times. So Vp is 2 times Ve. So 11.2 to thai, this will be 22.4. That is the answer for this particular question. Okay, so next question is also escape velocity. Let's answer this question. It says that escape velocity of a planet, escape velocity of planet having mass 6 times, and radius 2 times that of earth is, answer choices are root 3 VE, 3 V escape, root 2 V escape, 2 times V escape. That is a question which is given to us. What is the escape velocity as per this? Now, we have seen that escape velocity, we have seen the formula of escape velocity as basically related to the mass of the body and radius of the body. Mass and radius. Let me tell you this. Escape velocity is 2gr under root. Another formula I gave you, 2gm by r under root. That means this escape velocity is proportional to mass over r under root, right? Now, there's a planet. Escape velocity on planet, escape velocity on earth is equal to mass on planet, radius on planet, radius on earth, mass on earth, something like that. So mass 6 times, radius 2 times. So 6 over 2 under root 3. So escape velocity will be root 3 times escape velocity on the surface of earth. So as I told you, gravitation is a chapter which is going to take 2 lectures. So I'm going to cover gravitation. Next lecture mein I'm going to discuss with you Kepler's laws, gravitational Kepler's 3 laws I'm going to discuss. Orbital velocity I'm going to discuss, and small concepts I'm going to discuss, and these 2 lectures will be sufficient. So just revise the concepts which I gave you. I'm sending you this in WhatsApp now soon. Just revise it, and I think that should be more than sufficient. So let me go back what we did today. Within 5 minutes, let me summarize, and then we go complete it. So I started with gravitation. I told you this formula, this gravitational attraction formula, and this gravitational attraction formula, Newton's g mm by r square. I told you universal gravitational constant, the value, dimension kaise nikalna hai, that I told you. After that, I told you how this basically mg, that is acceleration due to gravity, and universal gravitational constant कौन से formula से आपस में जुड़े हुए हैं, that is very important, and how density is to be related to the mass. So small g का value density में, ये important formula है, बाद में हमने इसको use किया. Capital G का formula not very important but keep in mind. Then I told you G किसके ऊपर depend करता है, और फिर हमने variation के साथ पोल और इक्वेटर पे G की वैल्यू कैसे निकालनी है वो हमने डिस्कस किया. After that, I told you कि पोल पे acceleration due to gravity is 0.018 is more than on equator. How it varies with the height, I gave you this exact formula, this approximate formula. ये आप use नहीं करेंगे unless until h is very small. Then I told you how G varies with the depth. This formula we have to use. Then how G changes with angular velocity and latitude. This formula you need to keep in your mind. Angular velocity के साथ कैसे related है. Then the most important part was the escape velocity. So how much energy should I give to a body so that it escape the gravitational pull of earth. ये मैंने ड्राइव किया. escape velocity का फॉर्मूला आपको ड्राइव नहीं करना है, लेकिन आपको escape velocity का ये फॉर्मूला gm by r, g2gr, ये 2 फॉर्मूले याद करने हैं, और तीसरा फॉर्मूला इन डेंसिटी. ये 3 फॉर्मूला एस्केप वेलोसिटी के आपको याद करने हैं, और ये चीज एस्केप वेलोसिटी किस पे डिपेंड करती है. देन आई टोल्ड यू दैट देयर वर सम क्वेश्चंस आस्क्ड इन द प्रीवियस इयर्स एयरपोर्ट अथॉरिटी ऑफ इंडिया. दीस 2 क्वेश्चंस आई डिस्कस विद यू, एंड देन आई गेव यू सिमिलर क्वेश्चन, एंड असाइनमेंट वाज आल्सो सेंट टू यू. एंड नाउ आई एम आल्सो सेंडिंग दिस डॉक्यूमेंट जो मैंने आपके साथ डिस्कस किया. आई एम सेविंग दिस डॉक्यूमेंट and sending this document to you. You can see that on the WhatsApp group. Let me make some more announcement. You need to take mathematics seriously. Lengthy questions आते हैं और revision of सारे syllabus का आपको करना है. Similarly, जो quant है, reasoning है, that you need to take seriously. If you want to clear this exam, तो आपको ढंग से seriously इसको preparation करना है. Questions are not easy. Questions are ticklish also. Lengthy questions हैं, practice करनी पड़ेगी. We will do that. I am just telling you what is the most important part. मैंने 2 बकेट आपको बताई थी. एक में सबसे इंपॉर्टेंट क्वेश्चन जहां से आते हैं, और एक में क्वेश्चन बहुत जहां से रिपीटेडली नहीं आते हैं, बट वी नीड टू रिवाइज एंटायर सिलेबस. till gate we will go with slow pace and after gate we will increase the pace. I'm sure जो मेरी lectures चल रहे हैं जैसे फिजिक्स मेड सिंपल, उसको आप रिवाइज करते रहो, दे विल गिव यू एन आइडिया कि दिस टॉपिक्स आर नॉट डिफिकल्ट, दे आर वेरी इजी। हमें सारा नहीं पढ़ना है, जैसे ग्रेविटेशन को मैं आपको 1.5 घंटे में ग्रेविटेशन को कंप्लीट कराऊंगा, उसके बियॉन्ड क्वेश्चन नहीं आएगा। सिमिलर टू दैट एंटायर फिजिक्स आई थिंक 50 40 50 60 आवर्स में वी कैन डू। Similarly, Tyagi sir will tell you mathematics, reasoning we will do, but we will do that. Fine. Thank you. See you in the next class.